Good evening, dear students. Yes, so in the last class, we have completed the chapter alcohol, phenols, and ethers. Okay. Yes. So organic chapters, we have completed two chapters organic. So first was haloalkanes and haloarenes. Then we have discussed about alcohol, phenols, and ethers. Okay. So this is the next chapter, that is aldehyde, ketones, and carboxylic acid. Okay. So we are going to discuss today about the topic aldehyde, ketones, and carboxylic acid. So these are the different functional group, right? So different organic compounds, they have different functional group, right? So in organic chemistry, you have seen there are many organic compounds, okay? And in such organic compounds, there is a group of compound which contains carbonyl group, okay? That is, it consists of carbonyl group. So in organic chemistry, so there are n number of organic compounds. In that, in so many compounds, there is such a group that is called as the carbonyl group, which is represented as C double bond O. Okay, how it is represented, students? C double bond O. Okay, so uh, these carbonyl groups. Okay, so in what type of functional groups they will be? So first is the aldehydes. Okay, aldehydes, then ketones. Okay, carboxylic acid. Then again, where you can see this, your carbonyl group, you can see them in esters. Okay, so these are some of the compounds where you can see this organic carbonyl group. Okay, so in acyl halides, okay, in acid derivatives, so in some of the acid derivatives also you can see this carbonyl group. Okay, that is acyl halide. Okay, so this is the acyl halide. Okay, then in acid anhydride. Okay, in acid anhydride. So how do you represent acid anhydride? So like this. Okay, so this is the acid anhydride. Then acid amides. Okay, amides. So amides are represented like this. Okay, so these are the what? These are the acyl halides. These are the acyl halides. Acyl halides. These are the acid anhydrides. Okay, acid anhydrides. Then this is amides. Okay, so in such compound, you can see, and esters. How do you represent esters? O R dash. Aldehydes, how they are represented? They are represented as CHO. Okay, R CHO. Ketones R C double bond O. Okay, R dash. And carboxylic acid is R C double bond OH. Okay, so these are the different compounds, organic compounds, where you can see the presence of the carbonyl group. Okay, so out of these compounds, we are going to study in this chapter about aldehyde, ketones, and carboxylic acid. Okay, so these are the functional group. How do we? So these are the functional group. Okay, so let us see. So each in the detail. Okay. So just a second. I'll just share the slide. Yes, I hope you can see the screen now. Yes. Okay. Okay. So let us start. Okay. So we are going to discuss in detail about aldehyde, ketones, and carboxylic acid. Yes. So let us start. So the organic compounds. Okay. So the organic compounds which has the this bond. Okay, carbonyl group. Okay, which has the carbonyl group, that is C double bond O group. Okay, they are called as the carbonyl compound. So the organic compound which has this C double bond O group, they are called as what? They are called as a carbonyl compound. Its general formula is CnH2nO. So N is, it can be 1, 2, 3, 4, and so on. So these carbonyl compounds are basically, they are grouped into two categories. First one is the aldehydes, another one is the ketones. So in aldehydes, okay, there is a, it is a monovalent group, okay. So only one bond get attached with the carbon. So only one of the bond, it will get attached to the carbon, okay. And another will be hydrogen. So this is called as a formyl group. Okay, it is called as a formyl group. And in ketones, okay, both the valencies, they are satisfied by the attachment of a alkyl group. Okay, and this is a bivalent group. This is a bivalent group. So this is about your aldehydes and ketones. Okay, so these compounds, what they contain? They contains the carbonyl group. Okay, so they are called as the carbonyl compounds. Okay, yes, fine. So we will see. Okay, so next we are going to see the nomenclature. Okay, nomenclature of aldehyde. So when we are seeing the common name, so there are, as you know, there are two systems to name the compound. So first is you can give the common name. Okay, and the second is by the IUPAC system. So common name, okay, they are derived how in aldehydes. Okay, so so in this system, what is done, the names of the aldehydes. Okay, how they are derived? They are derived from the corresponding carboxylic acid. Okay, by replacing the ending of IC with aldehyde. Okay, so whatever the carboxylic acids are there, the corresponding carboxylic acid, the IC, the last IC, okay, of the carboxylic acid is replaced by aldehyde. Okay, so these names are given from the name of source in Latin and or in Greek. For example, if we have formaldehyde, okay, formaldehyde, how it is represented? Okay, it is derived from formic acid. So formic acid, where it is present in the ant sting. Okay, it is present in the ant sting. So when a ant bites, okay, you get that red color, this, right? So why? Because so that time the ant will eject its sting. Okay, and the sting will enter in your the place where the ant has bited. Okay, so that time what it will release? It will release the formic acid. Okay, so formaldehyde, it is derived from the formic acid. Then propanaldehyde, it is derived from propanic acid. Then butyraldehyde is derived from buric acid. Okay. So the location of the subsequent in the carbon chain, it is indicated by Greek letters alpha, beta, gamma, and delta. So the place, okay. So the substituents of the further, whatever the substituents are present on the compound, okay, it is represented by alpha, beta, gamma, and delta. So let me give you one example. So CHC, CHOH. Okay. So this is what? This is the name is the acetaldehyde. So the name of this aldehyde is acetaldehyde. Now I have a benzene ring. Okay. And to this benzene ring, I have a what? I have a, so this is a benzaldehyde. Okay. So benzaldehyde. So this is a benzaldehyde. Okay. So you can see this is a monovalent. Okay. This is a monovalent. Okay, why it is monovalent? So you can see only one of the at one carbon atom only it is linked. Okay, then one more example I'll give you. So CH3, CH. Okay, so I'll take your Br, then CH2, C double bond O, H. Okay, so how you are going to name this? How you are going to name this, students? So whenever the substituents are there, you should see that the substituent should get the least number. Okay, so this is alpha and sorry, with respect to your what carbonyl group. So this is alpha and this is your beta. So whenever you are numbering, okay, whenever you are you are giving the substituents the numbering, you have to give this, okay, from carbonyl group, and you should see that the substituent should get the lowest number. So what is the this? So it is beta bromo. Okay, beta bromo. Then 1 2 3 4 4 carbon means it is butylaldehyde. Okay, Butyraldehye. Okay, so it is butyraldehyde. So okay, so it is butyraldehyde. So this is the name of the compound. So like this we are going to name, give the IUPAC, that is your common name. Okay, this way we are going to give the common name. Next, let us give the nomenclature. So IUPAC system. Okay, when you are giving the IUPAC system, so what we are doing? Okay, so IUPAC system, in the IUPAC system, aliphatic aldehydes, they are named as alkanal. Okay, they are named as alkanal in the IUPAC system. Okay, in the IUPAC system of your aldehydes, they are named as alkanal. Okay, so when the your CHO group, when this your aldehyde group is attached to the ring, okay, that is your carbaldehyde is added after the word cyclo. Okay, now so if I have a benzene, okay, with the CHO group, so it will be benzaldehyde. So just now we have seen. Okay. So similarly, the names are given. Okay. So if I give like this CH3, CH, CH3 and CHO. Okay. So what is the name? So with respect to carbonyl, this is first, okay, carbon, second carbon and third carbon. Okay. So this is the substituent. So how I am going to give the name? Name it is 2-methyl propanol. Okay, it is 2-methyl propanol. Okay, you are going to replace your en with al. Okay, that is al means aldehyde. Okay, then similarly one more I'll give you. CH3, C, yeah, OCH3, CHO. Okay, so how you are going to give this name? So with respect to aldehyde, so this is alpha, this is beta. So this is alpha methoxy. Okay, alpha methoxy. How many carbons are present? 3 carbons. So 1, 2, and 3. So it is alpha methoxy propanol. Okay, alpha methoxy propanol. So this is the IUPAC name. This is the IUPAC name. Okay, so how we write the common name? So this is the IUPAC name. Common name, how will write? So we will write the common name also. Just see how to write. So IUPAC name they will ask you. Okay, but you need to know the how to write the common name also. Yes, how to write the common name. So common name, we are going to write how? So it will be again alpha methoxy. Okay, alpha methoxy. So propion aldehyde. Okay, so we are going to replace the propanoic acid, right? It is propanoic acid. So a carboxylic acid, whatever IC is there, that will be replaced by aldehyde. So alpha methoxy propanaldehyde. Okay, so this is the how we are going to write the IUPAC and your common name. Okay, so one more I'll give you. Okay, and then we will go for the ketones. Okay, so CHO. So this is with respect to aromatic compound. So how you are going to name? Yes. So with respect to your carbonyl group, so this is 1, 2, and 3 position. 3 position means it is meta. Okay, so let me write first the common name. So I'm writing the common name, okay, and then I'll write the IUPAC name. So how will be the common name? It will be beta bromo benzaldehyde. Okay, meta bromo benzaldehyde. And what is the IUPAC name? What will be the IUPAC name? 1, 2, 3. So 3 bromo benzaldehyde. Okay, 3-bromo benzaldehyde is the name of the compound. Is it clear? Yes. So let us go next for the nomenclature of ketones. Okay, nomenclature of ketone. So in this system, the names of the ketones, they are derived by naming the two alkyls or the aryl group. Okay. So whatever the alkyl and the aryl groups are there. Okay. So this is the ketone structure. So you have to name this alkyl or the aryl group. Your R and R dash, it can be alkyl or a aryl group. Okay, bonded to the carbonyl group. So further, whatever the substitution is there, it has to be indicated by alpha, alpha dash, beta, beta dash. Okay, so because both side, no. So one will be alpha, the other side will be alpha dash. Beta, this side will be beta dash, like that, and so on. Okay, so the naming, first you have to do the naming of the two alkyl or the aryl groups which is bonded to the carbonyl group. Okay, and you have to give the location based on the this. Okay, so let me give you example. Okay, CH3 C double bond O CH3. So how we are going to name this compound? Yes, so these are the methyl groups. Okay, these are the methyl groups. So how you are going to name? So it is yes. How you are going to name this compound? So it is dimethyl ketone. Okay, dimethyl ketone. Okay, or you can the common name, it is acetone. It is called as acetone. Okay, it is called as acetone. And IUPAC name. So if I give the numbering 1, 2, 3, so it is propane. Okay, propane 2 on. Okay, so this is the IUPAC system. Okay, this is an IUPAC system. So common name, you have to name the alkyl or the aryl groups. Okay, and in IUPAC system, you have to attach what? You have to replace the E of the ketones by on. So in aldehydes, what we are doing? E of the alkanes is replaced by al. Okay, in case of aldehyde group attached to a cycloalkane or benzene ring, then the word carboxyl carbaldehyde is used as suffix in both the system, and in ketones E of the alkanes is replaced by on. Okay, so these are the things which you have to remember. So let us see some of the examples now. Okay, let us see some of the example. So if it is CH3 C double bond O CH2 CH2 CH3, how will you give? Tell me the common name, tell me the IUPAC name. Yes, common name, how it will be? So this is what? This is methyl group. Okay. And this is what? This is a propyl group. Okay. This is a propyl group. So you have to follow the alphabetical order. So which will come first? M. So it will be methyl. Okay. N-propyl ketone. Okay. So this is the your common name. IUPAC name. Count the number of carbon atoms. So it is 1, 2, 3, 4, and 5. So it is pentane. Pentane at 2 position you have ONE, on. Pentane to on. Okay. Then take one more example. CH3, CH3. Okay, CH3, CH2. No, not like that. Let me take. Okay, so CH3, CH, CH3. Okay, then C double bond O, CH, CH3, and CH3. Okay, name this compound now. How you are going to name this compound? So again, start it from anywhere, we will get the same. Okay, it is a symmetrical ketone. So what will be the common name? The common name is, so this is isopropyl group, right? This is an isopropyl group. So you have two isopropyl groups. So it is di-isopropyl. Okay, di-isopropyl ketone. Okay, and what is the IUPAC name? What is the IUPAC name? It is 2,4-dimethyl, 2,4-dimethyl pentane. Pentane. And third position, you have one. Okay, so 2,4-dimethyl pentane 3-one. Okay, so these are the numbering. Understood? So note this, very important. So if aldehyde and ketone, both groups are present, then name the aldehydic group. Okay, then name aldehydic group is written in suffix as al. Suffix means the word which is written at the end. And the name of the ketone is used as the prefix. Okay, which is written as oxo. So in such a compound where both aldehyde and ketone are present, at that time you have to use the aldehyde al as a suffix and oxo as a prefix in such compounds. Is it clear? Okay. Okay, so these are some of the compounds which we have discussed. Okay, so aldehyde, the common name is acetaldehyde. Okay, this one. IUPAC name is ethanol. Okay, because the carbon, how many carbon atoms are there? There are two carbon atoms, right? 1 and 2. So it is ethanol. Okay, then next is this compound. So it is cyclo because it is a cyclic ring and it is 6-membered ring. So it is hexane and this group is present. So it is carbaldehyde. Okay, and again here cyclohexane carbaldehyde. Okay, IUPAC name. Then with respect to this compound, write the, so your carbonyl group should get the least number. So we have named it as 1, 2, 3, 4, 5. Okay, so 5. So it is pent. Okay, then at 3 position you have ene. Okay, and al. Al means the suffix of the aldehyde. Okay, so pent 3 in al. Then the next compound is the this compound. Okay, so you can see with respect to your aldehyde, so first and second position. So at beta you have methyl and you have a cyclopentane carbaldehyde. And with respect to IUPAC, you have to name it as 2-methyl cyclopentane carbaldehyde. Okay, then this is orthonitro-benzaldehyde. Here it is 4-nitro-benzaldehyde. Okay, yes. So like this, you are going to name the compound. So this compound, okay. So how you are going to name this compound? Just see. So this is 1, 2, and 3. Okay, so it is acrolein. The common name is acrolein. And the IUPAC system 1, 2, 3. So it is pro. Okay, at 2 position you have ene and al. So pro 2 ene al. Okay, at second position you have a double bond. So double bonds are represented by en, and aldehyde has the suffix as al. Okay, next compound is this. So 1, 2, 3, 4, and 5. So the name is valeraldehyde. Okay, valeraldehyde. So the name is pentanal. Okay, pentanal. Okay, then here you can see. So this is 1, 2. So phthalic aldehyde. Okay, and the name is benzene 1, 2 carbaldehyde. Okay, so this is the some of the compounds where we have seen the common name as well as the IUPAC name. So this is with respect to ketones. Okay, just see the compounds with respect to ketone. So this is acetone. Okay, that is dimethyl ketone, common name, and IUPAC name is propanone. Okay, 1, 2, 3. So it is propane and on is the suffix on. Then this 1, 2, 3, 4, 5. Okay, this is methyl, this is a propyl, so it is methyl and propyl ketone, or it is pentane 2 on. Okay, because at 2 position you have ONE, that is your carbonyl group is present. with suffix ONE. Then this particular compound 1, 2, 3, 4, 5. Okay. So what you have? So you have two iso group. Okay, you have two iso group, that is symmetrical iso group near the your ketone. Okay, so you have diisopropyl ketone, that is a common name, and the IUPAC name is at 2 and 4 position you have methyl, so it is 2, 4 dimethyl pentane. At 3 position you have one. So mark this as very, very important. So these two examples, okay. Then carbonyl group should get the least number. So 1, 2, 3, 4, 5. The IUPAC name is what? So again, here you can see there is one aldehyde group and there is one ketone group. So when you have one aldehyde and ketone, what did we say? That the ketone should get the prefix, okay? So 3-oxo, then you have 5. So it is pentanal, okay, pentanal. So your aldehyde will get the suffix position and your oxo, that is your ketone, will get the prefix position. Okay. Then next is this. So alpha beta, so beta methoxy cyclohexanone and or 2-methoxy cyclohexanone. Okay, so these are some of the compounds where we have named their common name and we have given their IUPAC nomenclature. Okay, next we are going to see the structure of the functional group. Okay, how we are going to explain the structure of this carbonyl group. Okay, now how is the carbonyl group? So carbon is there. Okay, so this is like this. Okay, so like this it is. So this is a sigma bond. This is a sigma bond. This is a sigma bond. Okay, and there is a pi bond. So here there is a pi bond. Okay. Okay, so how this pi bond is formed? So pi bond, it is formed by the perpendicular overlap, right? So by perpendicular overlap. So between this and like this, the pi bond is formed. Okay, now here the carbonyl group. Okay, what is that? It is a sp2 hybridized. Why it is sp2 hybridized, student? Because you have a double bond, right? You have a double bond. So this carbonyl group is sp2 hybridized because you have what? You have a double bond. Okay, so it forms 3 sigma bonds. So 1, 2, and this is 1 sigma bond. So 3 sigma bonds are formed and the carbon is sp2 hybridized. Okay, so in this 3 sigma bond, one lies in one plane, okay, the unhybridized p orbital. So here you can see, okay, so this is okay, when we are talking about the p orbitals, okay, so the unhybridized p orbital of the oxygen, okay, it will overlap. So the unhybridized p orbital, what it will do, it will overlap with the p orbital of the oxygen atom. Okay, so like this the overlap takes place. Okay, the overlap takes place between the p orbitals of carbon with the empty p orbitals of your oxygen atom. So these are the p orbital, unhybridized p orbital of carbon, and this is the unhybridized p orbital of oxygen, and this overlap takes place. Okay, and what it forms? It forms a pi bond. Okay, it forms a pi bond. So this pi bond, it is like a cloud formation. So one cloud above, one cloud below. Okay, in the plane of the molecule, and the angle which is made, it is approx 120 degrees, 20 degree. Okay, and it has a planar structure. Okay, what is the structure? It is a planar structure. So if you see the structure, okay, so this is a sigma bond, this is sigma bond, this is sigma bond, and like this, the overlap takes place between the unhybridized orbital of p and or that is carbon and oxygen. Okay, so this is so that will give you like this the oxygen. So one cloud is above and one cloud is below. Okay, so like this, the angle which is made, okay, the angle which is made, uh, this is approx what I said, it is 120 degree. The angle which is made by the structure, that is a planar structure, it is 120 degree, the complete structure. Okay, so this is the structure of the functional group. So here the CO bond. So this CO bond, it is a polarized bond. Okay, CO bond is a polarized bond. Why? Because oxygen atom is a high highly electronegative atom. So what it will do, it will tend to pull the electron towards itself. As a result, polarization occurs. The oxygen will get the partial negative charge, and carbon will get the partial positive charge. Okay. So your carbonyl carbon is a electrophile. Okay, carbonyl carbon is an electrophile. That is, it acts as a Lewis acid. Okay, it acts as a Lewis acid. And your carbonyl oxygen, it is a nucleophile. Okay, it is a nucleophile which acts as a Lewis base. Okay, which acts as a Lewis base. So how the polarization takes place? So the polarization takes place like this. Okay, so the attack on the carbonyl carbon and this polarization bond takes place. As a result, carbon will get the positive charge and your oxygen will get the negative charge. So like this, the polarization occurs. Yes, is it clear? Okay. So next we are going to discuss the preparation of aldehydes. Okay. So yes, so this is the overlapping what I have talking about. Okay, so this is the unhybridized p orbital of carbon and this is the unhybridized p orbital of oxygen, which have overlap to form the pi bond. Okay, one pi cloud is above and one pi cloud is below. Okay, so this you can see pi cloud above and below. And this angle, okay, which is made, it is 120 degree. Okay, and there are three pi sigma orbital. And this carbon is what? It is sp2 hybridized. So these things you have to remember. Is it clear? Okay, let us go for the next one. So next we are going to see the methods of preparation, how we can prepare aldehydes and ketones. Okay, what are the methods of preparations of aldehydes and ketone? So first is by oxidation of alcohols, by doing a controlled oxidation, oxidation. So we are doing controlled oxidation. We are supplying the oxidation, we are doing oxidation. We are supplying the oxygen in controlled manner. Okay. So aldehydes and ketones, they are how prepared? They are generally prepared by this controlled oxidation. Okay. Or you are going to take primary or secondary alcohol. Okay. You are going to take primary or secondary alcohol. What you are going to do? You are going to do oxidation. There are the reagents used, strong reagents used like potassium dichromate. Okay. Your potassium dichromate and in the presence of dilute sulfuric acid. Okay, potassium dichromate in the presence of dilute sulfuric acid. Okay, so primary alcohol will be converted to aldehyde and your secondary alcohol will be converted to ketone. Okay, secondary alcohol will be converted to ketone. So primary alcohol is converted to aldehyde and secondary alcohol is converted to ketone. So respective aldehyde and ketones are formed with respect to primary and secondary alcohol by doing strong oxidation. So how this oxidation is occurred? By using the strong oxidizing agent. So which strong oxidizing agent we are using? We are using potassium dichromate in the presence of sulfuric acid. Okay. Yes. So let me give you example for this. Okay, let me give you example for this. Suppose I take ethyl alcohol, CHC, CH2OH. Okay, react it, do oxidation, that is K2Cr2O7 in the presence of H2SO4. What will be the answer? And one more, CH3, CH, CH3OH. Okay, do oxidation in the presence of K2Cr2O7 in the presence of H2SO4. Yes, what will be the answer? What is the answer for this? This will be a aldehyde CH3CHO plus H2O. Okay, and this will be CH3 C double bond O CH3. Okay, plus H2O. So what is happening in oxidation? You are removing the hydrogens. Okay, you are removing the hydrogen. Is it clear? Okay, so we are doing oxidation in a controlled manner. Okay. So if we have a primary alcohol, okay, when we have the primary alcohol, if you are doing like quietly, okay, if you are doing it in a controlled this measure, so first it is converted into aldehyde. Further, if you again oxidize it, Okay, further, if you again oxidize it, it is converted into carboxylic acid. Where it is converted into carboxylic acid. Understood? Okay. So aldehydes, primary alcohols, they are converted into aldehydes. Aldehydes again, further oxidation will give you carboxylic acid. Okay, thus oxidation of primary alcohol is made at a temperature much above the boiling point of aldehyde, and thus aldehydes are vaporized out and prevented from being oxidized. Okay, so the reaction is taking place at a higher boiling point, okay, of that of the aldehyde. Okay, so this is the reaction. So primary alcohol, they give you aldehyde. Secondary alcohol, they give you ketones. Okay, so this is what you have to remember. So PCC, pyridinium chlorochromate in dichloroethane, and PDC, pyridinium dichromate in dichloroethane, okay, methane. Then Jones reagent, that is formic acid plus H2SO4 in acetate. So these are some of the selective oxidizing agent. So mild oxidizing agent which we are using. So primary alcohol will get oxidized with formic acid in the presence of pyridine, Collins reagent, and AgO2 at 250 degrees Celsius. So these are some of the reagents. Okay, these are some of the reagents which by making use of these reagents you can do the controlled oxidation. Okay. Yes. Next is dehydrogenation. Okay. So in the last alcohol, phenols, ethers also we have seen what is dehydrogenation. Dehydrogenation means what? Yes. What do you mean by dehydrogenation, students? Dehydrogenation means removal of hydrogen. Okay. Removal of hydrogen. So removal of hydrogen is your dehydrogenation. Okay, so what we are doing in dehydrogenation? So aldehydes and ketones, how they are obtained? They are obtained when the vapors of this primary alcohol, okay, and secondary alcohol, they are heated with a heavy metal. So a heavy metal has to be taken, okay, heavy metal catalyst, okay, like your copper or silver. So you can take copper or silver. So you are they have taken copper. Okay, you are taken copper. So what we are doing, we are going to heat it, primary or secondary alcohol, we are going to pass it over the heated alcohol at 573 Kelvin and dehydrogenation reaction takes place. Okay, so this is the reaction. So primary alcohol, I represented as RCH2OH. Okay, in the presence of copper at 573 Kelvin, what you get? I'm going to get a ketone plus hydrogen gas is liberated. Then when I have a secondary alcohol, okay, when I have a secondary alcohol at copper at 573 Kelvin, what I'm going to get? I'm going to get a ketone plus hydrogen gases liberated. Okay, so these are the examples. This I have taken ethanol. Okay, and this is a uh, uh, propanol. Okay, so this is a 1, 2, 3. So isopropyl alcohol. Okay, isopropyl alcohol. Okay, yes. So ethanol, okay, or you call it as ethyl alcohol. When you heat it with copper at 570 Kelvin, you're going to get acetaldehyde. Okay, and when you have isopropyl alcohol heated over copper at 570 Kelvin, you're going to get ketone, that is acetone. Okay, yes. So another dehydrogenation, another method of preparation, that is dehydrogenation reaction. Yes. Okay. Next is by ozonolysis of alkene. Okay, next is by ozonolysis of alkene. So we are going to do ozonolysis. Ozonolysis means what, student? Addition of ozone. Okay, ozonolysis means addition of ozone. So what we are going to do on alkene? So we are going to take a alkene. Okay, so alkene, I am going to take CH double bond CH2. Okay, so I am going to take a alkene. I'm going to react it with ozone. Ozone is represented by O3. Okay, ozone is represented by O3. Okay, so how we are going to do? So let me take a alkene. So alkene reacted with O3. Okay, what I'm going to get? What I'm going to get? So O, okay, O. So three molecules of oxygen has to be added. So like this. Okay, a molecule, and so this will cut like this, and this will cut like this. Okay, so it will break. So this in the presence of, again, further in presence of zinc dust and water. Okay, what I'm going to get? One, I'm going to get ketone. Another, I'm going to get a again one ketone. Okay, so this will be aldehyde or ketone. So it will be aldehyde or it will be a ketone, aldehyde or a ketones. So breakage will takes place like this. So like this, okay, and like this. So aldehyde and ketone is formed. Is it clear? Okay. So whenever you have a branch alkene, you are going to get ketones. Whenever you have unbranched alkene, you are going to get a aldehyde. So let us see example. Let us see example. So if I have RSCH3, CH double bond CH2, and CH3, add a oxygen molecule, ozone molecule. What I'm going to get? Do not disturb anything. Okay, rest all will remain the same. Rest all will remain the same. Just write ozone. So three molecules of oxygen has to be added. So this will undergo cleavage in the presence of zinc dust and water. So one cleavage here, another cleavage here. So what I'm going to get here? I'm going to get CH3, C, CH3 double bond O plus HCHO. Okay, plus CHOHO. So one is a ketone, another is a formaldehyde. Understood? Yes. Is it clear? Very, very important. Mark this as important. Very, very important. Addition of ozone. Ozone, that is O3 molecule, we are going to add across the alkene, and we are going to cleave. It undergoes this. Okay. Further, so ozonide will get cleaved by using zinc dust. Okay. And water. So it will give you aldehyde, ketones, or mixture of both. Is it clear? So very, very important. So next is from alkyne. Next is from alkyne. Okay. So aldehydes and ketones, they can be prepared by the hydration of alkynes. What do you mean by hydration, student? Hydration means addition of water. Okay. Hydration means addition of water. Okay. Hydration means addition of water. So what we are going to do? Aldehydes and ketones, it can be prepared by the hydration of alkyls. Okay. Alkyls in the presence of dilute H2SO4, or you can use 1% HgSO4. Okay. So they have taken a alkyne. So alkyne is a triple bonded compound. So you have taken a acetylene. They are going to react it with water in the presence of dilute H2SO4 and 1% of HgSO4. What I am going to get? I am going to get a enol keto form. Ketoenol tautomerization. Okay, ketoenol tautomerization. So I am going to get CH2 double bond CH. Okay, and here I am going to get a like this. So what will happen? This will polarize this bond. Okay, this will polarize here and this will be here. So what I'm going to get? I'm going to get CH3, C double bond O H. So keto, so this is enol form and this is a keto form. Enol means in double bond and OL, that is your alcohol is present, and here only keto group is present. Okay, yes. So this is the example. Okay, we are going to do hydration. We are putting a molecule of water. Okay, so acetylene will give you aldehyde, other alkynes. Leaving acetylene, if you take anything, you are going to get a ketone. Okay, you are going to get a ketone. Suppose I will take CH3, CH, double bond, CH, CH3. So this is what? This is a butylene. Okay, butylene. So I'm going to add water in the presence of H2SO4 and 1% HgSO4. What I'm going to get? What I'm going to get here? It will be CH3. Okay, CH3. CH. So COH, CH, CH3. Okay. So what I'm going to get now? This will attack here. 3, 4, 5, 2, 2, 4. And this will attack here. So what I'm going to get? I'm going to get, so this is a enol form and this is a ketone form. So CH3, C double bond O, CH2, CH3. Okay, so like this ketone and enol form. Is it clear? Yes, so these are the four methods of preparation which we have seen. Okay, just we'll revise. So which are methods of preparation we have seen? First one is oxidation. Okay, we are going to do oxidation of alcohols by using oxidation of alcohol by using potassium dichromate with HSO4. We are going to oxidize primary alcohol to aldehyde and secondary alcohol to your ketones. Okay, then we are going to see what the dehydrogenation reaction, that is removal of hydrogen molecule. Okay, with primary alcohol, we are going to get acid aldehyde, and with secondary alcohol, I am going to get the ketones. Okay, then by ozonolysis of alkene, what we are doing in ozonolysis molecule, we are going to add one molecule of ozone O3 across the alkene. Okay, we are going to get a ozonide, then cleavage. It cleaves with the help of zinc dust and water to give you aldehyde and formaldehyde. Okay, so depends. So branch alkene will give you ketone, unbranched alkene will give you aldehydes. Okay, so these are the reactions. So alkynes also we have seen, that is hydration reaction with the dilute H2SO4 and HgSO4 at 60 to 80 degrees Celsius. When acetylene is reacted with water, you are going to get a ketoenol tautomerization. Okay, so whenever you have acetylene, you are going to get aldehyde. Other alkynes will give you ketones. Okay, yes. Next, let us see the preparation of aldehydes. Only, especially you are going to prepare only aldehydes, okay, not ketones. By these methods, you cannot prepare the ketones. But the previous methods, four methods, what we have seen, from that you can prepare both the aldehydes also and the ketones. Ketones also, okay. From your these name reaction, we can only prepare only the aldehyde. The first is from acyl chloride. The first is from acyl chloride. So acid chloride. So how do we write the structure of acid chloride? So this is your acid chloride. So this is your benzoyl chloride. Okay, this is example of benzoyl chloride. So acid chloride, how we had written R CO double bond O Cl. Okay, so R can be your any alkyl or a aryl group. So this is benzoyl chloride. So benzoyl chloride, what we are going to do? We are going to do hydrogenation. Okay, we are going to do hydrogenated over the catalyst. Which catalyst we are using? Palladium on barium sulfate. What we are going to get? We are going to get a benzaldehyde. Okay, we are going to get a benzaldehyde, and this name reaction is called as the Rosenmund reduction. Okay, we are doing reduction. We are adding the hydrogen, right, and we are removing this electronegative atom. So acyl chloride is hydrogenated over catalyst palladium on barium sulfate, and this reaction is called as Rosenmund reduction. What it is called as Rosenmund reduction. Is it clear? Yes. Okay. So acid chloride, it is hydrogenated over a catalyst palladium on barium sulfate, and this is called as the Rosenmund reduction. Okay, let me give you one more example. Take CHC, C double bond O Cl. Okay, in the presence of H2, palladium and barium sulfate. What I'm going to get? Okay, what I'm going to get? I'm going to get a CHC double bond OH. So I have got a acetaldehyde. Okay, I've got a acetaldehyde. Understood? So the aldehyde which is formed, this can be further again reduced to alcohol. Okay. To prevent this, what we can do, the catalyst is poisoned by adding a small amount of sulfur or quinoline. So again, the further reaction should not occur. So whatever the catalyst we are doing, it is poisoned, okay, by adding a small amount of sulfur or quinoline. So formaldehyde. So from this method, formaldehydes cannot be prepared. Okay, because the formyl compound or the formyl chloride is unstable at room temperature. Okay, remember this. So acyl chlorides, can be converted into your aldehydes by doing hydrogenation over a catalyst, that is palladium, okay, on barium sulfate. And your what? Your formaldehyde cannot be prepared by this action. Is it clear? Okay. Next is from nitriles and esters. Next is from nitriles and esters. So nitriles. So again, Rosenberg reduction, very, very important. 2 marks question. Please mark it as important. Okay, important. Next, your from nitriles and this very important Stephen reaction. Another name reaction which is called as a Stephen reaction. So what we are doing here? 2 marks question. Okay. So nitriles, they are reduced to corresponding imine by stannous chloride. Okay, what is stannous chloride? SnCl2. Okay, in the presence of hydrochloric acid. Okay, which on hydrolysis gives you corresponding aldehyde. So this reaction is called as what? It is called as the stiffened reaction. It is called as the stiffened reaction. So what is done? So nitriles, they are reduced to corresponding imine. Okay, what is the imine? So this is the imine system. Okay, CH double bond NH. So this imine further will undergo hydrolysis to give you a aldehyde. And this name reaction is called as the stiffened reaction. So this is a general reaction RC double bond triple bond N, that is a cyanide reacting with stannous chloride, okay, plus HCl in the presence of HCl to give you imine. This imine further undergoes acid hydrolysis to give you what? The aldehyde. Okay, so let us give an example. So I'll give you example of CH3. I'll take I'll take it as CH3 and cyanide. Okay, reacted with stannous chloride in the presence of HCl. Okay, what I'm going to get? I'm going to get CH3 CH double bond NH, that is a imine. Okay, that is a imine. This imine further undergoes hydrolysis to give you what? CH3 CH double bond OH. Okay, so I'm going to get a aldehyde. Okay, I'm going to get a aldehyde plus ammonia is released. Okay, ammonia is released. So like this is the reaction. Okay, is it clear from nitriles and esters? Very important. Again, 2 marks questions. So both the reactions are important. First one is the Rosenberg reduction. Second one is the stiffened reaction. Okay, second one is the stiffened reaction. Okay. So you can alternatively, you can convert the nitriles. Okay, you can reduce them also to aldehydes by using DIBAL. Okay, diisobutyl aluminum hydride. So that is another reagent. Okay, followed by hydrolysis. You are going to get the aldehyde. So again, nitriles. So another methods by using the okay. So by using nitrile. Okay, so by using so by using nitriles, okay, by using nitriles. So what I'm going to do, I'm going to use this, that is dibyl diisobutyl aluminum hydride, okay, followed by hydrolysis. You are going to get what? I'm going to get a aldehyde. Okay, I'm going to get a aldehyde. So if double bond is present, then the double bond is not reduced by dibyl. Okay, by this, it is not reduced. Okay, so another example. So here you can see. So this will remain as it is. Only the cyano group will be replaced by your aldehyde group. Okay, so rest all will remain the same. Double bond is present. It will not be altered anything. So it will be as it is. Only CN, that is your nitrile group, is converted into aldehyde. Okay, esters are also reduced to aldehyde with respect to your diisobutyl aluminum hydride. So this is a ester. Okay, one group. This is another group. So it is a ester group. Okay, methyl, ethyl, methyl. Okay, you can say so another compound. So what you can do here? So what I can do here? Okay, C2H5. CH3, so ethyl methyl ester. So what you can have done? So what is done? So only this and this will remain. So this will okay. So this will be gone as a alcohol, and here your H will be added. So this is one aldehyde. that is acetaldehyde, and this is your alcohol. So with Dibal, okay, your reagent that also can be converted. Okay, so esters and nitriles, they are converted into aldehydes. Okay, yes. So next is the hydrocarbons. Okay, next is the hydrocarbons. So hydrocarbons. So again, we are going to see much in detail. Okay. So yes. So for today, so what all things we have discussed in today's class. So let us recapitulate it. Okay. So what all things we have discussed. So in today's class, we have discussed about what are aldehydes, what are ketones, what are carboxylic acids. So we have discussed about what are the carbonyl compounds, okay? What are the different carbonyl compounds and what are the different, in detail, we have discussed about aldehyde, ketones and carboxylic acid. Okay, then we have discussed about the structure. Okay, we have discussed about the nomenclature of aldehydes and ketone with respect to common system and the nomenclature, that is IUPAC nomenclature. Okay, then we have seen some of the compounds wherein we have named the common name as well as we have given the IUPAC name for both aldehydes and ketones. Then we have seen the structure of the carbonyl group, that is a functional group. Okay, then we have discussed the general methods of preparations for both aldehydes and ketones. So first one was the oxidation. Second is by dehydrogenation, then the ozonolysis of alkene, and then from alkyne. Then we have seen the preparation of aldehydes only for aldehydes. First one was Rosenberg reduction and second one was Stephen reaction. Okay. So by using diisobutyl aluminum hydride also you can hydrolyze, you can convert your nitriles and esters to the aldehyde. Okay. So the remaining thing we shall be discussing in the next class. I hope you have understood what all things have been discussed today. So the rest things we will be discussing in the next class. So thank you to the students. So I shall stop the class here. We'll continue in the tomorrow's class. Thank you.